right, hello everyone. I'm so excited to be here and talk to you guys today about a couple ideas that I've been pondering in the climate tech space. Today I'm going to be talking to you about how we can incentivize climate action with the blockchain. How can blockchain play a role in helping us develop better climate tech? So I want to start off with a story because I think it often gives us a better idea of what blockchain is interpreted by the outside world. Essentially, when I first started off in the blockchain space, I took to Reddit and I wanted to see what people were excited about, like what was the cool thing that everyone was talking about. And I went to Reddit and I saw one Redditor wrote this. I researched most. My conclusion is it's a crowd-based Ponzi scheme. Criminals, terrorists, money laundering. As you can see, blockchain generally gets a pretty bad rep. And I promise my drawings will get slightly better as we go on. I think that blockchain gets a bad rep because we generally associate it with something like Bitcoin. Now, Bitcoin is very energy intensive and people think that, how could something this bad possibly do any sort of good in the economy? And this is simply not the case. Now, as long-term crypto enthusiasts, we're often trying to think of, how can we apply blockchain to solve this problem? And a lot of the solutions that I've seen at the summit have even been like, okay, we have this wonderful technology, how do we use it to solve this big problem that we haven't been able to solve for many years now? This meme, I think, perfectly illustrates what blockchain solutions look like for real-world applications. Now, I'll save you the one minute GIF, but I think what I'm trying to show here is that we're constantly seeking ways that we can just tag on blockchain to different applications instead of actually understanding the problem. So what I want to talk to you about today isn't blockchain, crypto, Web3, or any kind of technology. I want to talk about climate. Why is climate such a uniquely difficult problem to solve, and why have we not solved it like we solved every other problem that exists today? So let's talk about climate. Why is climate hard? Climate hasn't progressed the same way technology or healthcare has over the past 50 to 100 years. It's simply not been the same. And this is because there's a lot of environmentalists that have been in this space for a very long time. And they're making slow, gradual, linear progress. But it's not anything special. The only difference is now we have things like greater battery efficiencies and wireless electricity and offshore wind turbines. We have all this new technology, yet we're not making as much progress as we'd like to. So my question is, we have all of this technology, why is it getting worse? Like exponentially worse. Climate is just not really paying attention to how technological trends are progressing. Yet we're just seeing that the global CO2 atmospheric concentration is increasing exponentially. Now I want to distill what I believe makes climate such a difficult problem to solve. The first is the problem with collective action. We're seeing that countries don't actually want to collaborate and work together because it's just easier for them to just do what's independently better for them. The collective action problem is basically when rational, self-interested decisions of individuals are essentially making the circumstances of the entire group a whole lot worse. There's no incentive for me as a country to try to cut greenhouse gas emissions because now I'm facing many more problems. For example, a lot of my economy may rely on greenhouse gas emissions, and now if I cut those emissions, my economy is suffering. Maybe this would help put it into better perspective on an individual level. This is why collective action doesn't really work, because everyone acting in the best interest of themselves makes life worse for everyone as a whole. In conclusion of this point, action on climate change cannot happen in silos. We simply cannot continue to work alone and do what's better for us as individuals. We'll have to make compromises. The second reason why I believe climate is such a difficult problem to solve is a time lag. We're seeing that climate is actually very interesting because as we start to make action today, we're not seeing the effects of this for decades or centuries to come. Now, there's two reasons for this. First is historical emissions. We've already produced so many greenhouse gas emissions that we aren't able to compensate for it. We not only need to get to net zero, but we need to be net negative. The second is politics. We're seeing that presidential elections are lasting 2 to 6 years, so presidential leaders are more incentivized to focus on short-term growth over long-term incentives. Put this into perspective, the average age of global leader today is 68 years old. That's just averages. Now think about the most powerful nations in the world. A lot of those averages are a lot higher, right? Like Joe Biden is almost 80. We're seeing that to reach net zero by 2050, which is a common benchmark for a lot of climate government organizations, these global leaders are not probably going to be alive by then. So they're making decisions right now that is going to impact us 30 years down the line, but they won't even be around to see the results of the decisions that they're making. Climate change is cumulative, not like any other problems that we've seen before, because it continues to get worse. The longer we wait to address it, the bigger the problem it becomes and the harder it gets to solve. Big climate policy, I believe, would have to offer concrete benefits outside of its impact on emissions to overcome this time disconnect. Something like greater job security or energy security, or even something like Bitcoin could be a great incentive for people to align their long-term and short-term growth. The third problem, I believe, is a pay now and pay later problem. We're seeing that we're not only having to pay now, but we're also going to be paying later for the consequences of our actions. Two reasons for this, because there are two costs that we see. First is a response to extreme weather. So if we look at problems like wildfires and floods, we're seeing that these problems are made exponentially worse by the results of climate change. Whereas also, these problems that used to exist are now worse because of the cumulative effects of climate change. The second is that now we have significantly higher fuel costs today as a result of trying to de-incentivize people from using fuels. This cost affects a lot of people very disproportionately. What this means is a lot of different nations will have to incur different costs depending on their unique climate situation, which sets the stage for conflict, not cooperation. We're the first generation of humans to start paying the price for a warmer world, and we're also the first to face costs as we try to address it. Now, today, I don't really want to be talking about the negative effects of climate because we already know those, but I truly believe that there's a couple of different pillars to creating an optimal climate solution. Specifically with incentivization, I believe that there's a huge role that blockchain can play, and it actually is needed in this case because I think we need new ways to align people. So if you're thinking about climate economics at this point, you're probably wondering, how do we get people to do the things that we want them to do? I see a lot of problems with climate economics today. There's not enough research, we're ignoring tail risks, we're focusing way too much on carbon taxes, carbon offsets, as if those are the only solutions to our very big problem. But that's simply not the case. What we're seeing is in the 90s and early 2000s, climate tech was a very difficult problem because green energy was very expensive. So climate economists were brought in to try to balance the economic trade-off with the environmental benefits of climate. But that's not the case anymore. With technology, costs of solar and wind power technologies are continuing to fall. So we're seeing that it's actually becoming a lot cheaper and more effective to switch to green energy. Decarbonization no longer involves a large amount of economic sacrifice. It just is a lot of willpower and investment. The other big problem with climate economics is we're still focusing on playbooks that were created by older people, and they did some of their best work when climate economics would have really hurt the economy. Today, what we're seeing is we're still operating by the same playbooks of these people who aren't, again, going to be alive by the time to 2050, and we're still focusing on the trade-offs that we could be making instead of the fact that we have so much more technology now. We have blockchain, AI, ML, all these amazing technologies that can help us solve these really big problems. I'll quote Max Planck now because I remember he said, "Science makes progress one death at a time." Now that's really interesting because we see that as science continues to evolve, we're not evolving our mindsets and our economics. I still believe that analyzing long-term trade-offs, we're focusing way too much on that instead of asking ourselves, how do we simply switch to green energy faster? So I truly believe blockchain is a key stepping stone in getting us there. How do we align short-term incentives, get people to think in the long term, while also getting more of that benefit without actually having to worry about economically compromising themselves? But why? Why is blockchain so uniquely adept to help us solve this problem? There's two different components of the blockchain that make it very important: verifiability and interoperability. Everyone's familiar with this, so I'll skip over this. Basically, what we're seeing is that with Web2 technologies, and if we just layer a layer of accounting on top of it, see that complex climate problems cannot be reduced to simple price signals. So something like this, where we have a lot of different factors like scale of similarity, dominance effects, types of similarity, productivity, all of these different ideas cannot be reduced to a simple price signal. So if we were to compare the economic impact of one area over another, we're not going to be able to do this by simply using Web2 technologies, as a lot of the data might be tampered with. So I'm going to try to reduce this to two different diagrams. If you see the first plot of land, it's continuous. The second is fragmented. Everyone knows here that continuous land is going to have a greater contribution to biodiversity and the biosphere in general. So something like this could easily be reduced to a price signal if we have satellites and other data that's being collected in a decentralized way, and we're able to actually monitor the real-time effects of how our technology is impacting the environment. Programmable money is really interesting because we can pass data from increasingly robust models throughout the economy. Now, what this means is that as long as we have economic models that we can try out and technology that we're interested in, we can put those into the economy and see how they might interact with the environment. Let's give an example of this. These are smart contracts. Let's say you go to a hotel, right? And the hotel manager tells you, if you turn off your lights and you use a little bit less water and you have to take shorter showers, we'll give you 10% of your stay back. That's really cool because now you have a smart contract that can automatically dispense you rewards by incentivizing you to act cleaner. A better example of this would be farmers insurance. Farmers insurance is a notoriously hard problem because insurance companies are constantly ripping off farmers and saying that, there's many different reasons why your crops didn't grow. There's many different reasons why this could have happened. But with blockchain, we can actually ensure that people are getting the rewards that they deserve transparently and fairly. There's a really big reason for this is because farmers are now de-incentivized from growing produce because they think it's a risky business. Insurance isn't really even helping them. So instead, what we see is that we can create a more financially stable future for farmers, but we can also create a more globally secure supply chain. We're going to see a shift in global consumption habits. As I said before, collective action starts with the individual. It's not about entire countries. We can no longer rely on legislation. Smart contracts are really a great tool for incentivizing participation in global green initiatives and getting people to act the way that we want them to. So these are two different ideas that have kind of been experimented with, and more farmers are looking at things like regenerative farming and carbon offsets because they know that there's some kind of assurity with smart contracts that they'll get their money back or that an organization would be incentivizing them to try greener alternatives. Green smart contracts have been hampered by the inability of blockchains to interact meaningfully with data about the state of the world. Now what this means is something like satellite data or blockchains cannot really interact easily together, and that creates huge problems. Today, what we're seeing is blockchains can interact with multiple oracles, which can interact with AI analytics, IoT data, market data, all these different ideas, which can reduce these complex ecosystems and environments to a single price signal, not like Web 2 can do. So this is an example of something we might see: regenerative agriculture, satellite remote sensing data, which would go through a network and a smart contract, and then we would get some kind of reward for farmers to participate in regenerative agriculture. Blockchain's impact, I believe, though, goes well beyond climate tech. I think we can take this same understanding of how we can make improvements with the way that we're thinking about the blockchain to many other sources. We truly need a 10x improvement to be able to reach the next billion blockchain users. And this is because until the point where users feel that the blockchain is significantly better than their current solutions, we won't see a switch happening. So how do we get there? We're going to be needing a lot more technological improvements. Minor improvements, I truly believe, will make the world of a difference, especially when we're considering how it can be applied to many different applications. This is an example of something that I've been working on for the past year, basically in cryptographic automation and how we can automate the discovery of vulnerabilities in blockchains. This is really interesting because with this kind of technology, we can make it more accessible for people to access the blockchain and do things like access the blockchain through SMS technologies. Incremental progress in even technology is bound to bring us towards more impactful use cases for the future. Now, Ethereum was built around this sense of community and this sense of belonging and innovation, really. What we want to see now is initiatives and solutions to the world's biggest problems being run by communities and people and not legislation and the government, because we truly have to take this problem into our own hands and figure out how we can make a true impact in the climate space. Thank you.